My name is Emilio Vega, and I'm a recent graduate of Rowan University with a Bachelor's of Science in Physics. Dr. Nicholas Whiting and I have recently been investigating the potential contribution to the magnetic field of Jovian planets due to parahydrogen interactions within the atmosphere, specifically on Jupiter. So when I first started researching this topic, I came across three theories that really resonated with me, and two of which coincided or complemented each other quite nicely, whereas the third one presented something new to the table. However, it did not undermine the other two theories that I will be talking about. So, the first theory that I want to begin with was presented by Kong and his associates back in 2016, and they worked under the premise that Jupiter was comprised of three layers. So this outermost layer is made primarily out of hydrogen gas, which can exist in two states. It's either parahydrogen, where the nuclear spins are anti-parallel, one up or one down, or it could be orthohydrogen, where the nuclear spins are parallel, either both up or both down. Now, the ratio of parahydrogen to orthohydrogen is about 1:1 at liquid nitrogen temperatures, or essentially 77 Kelvin. So, in this outermost layer of Jupiter, the aerosols and parahydrogen are interacting such that parahydrogen's nuclear spin order gets reoriented. It becomes orthohydrogen when it collides and interacts with these aerosols. So, in regions where there's a lot of aerosols, a lot of parahydrogen interacting, there's going to be a lot of orthohydrogen. And because orthohydrogen has a magnetic moment due to the coupled spins and parahydrogen does not, orthohydrogen tends to couple with itself. And if this happens at a large scale, it can generate a hyperpolarized region in the outer layer of Jupiter. Alongside this hyperpolarization process possibly occurring, there are zonal winds. And what I mean by that is that there are winds in a cylinder shape or a spiral shape that are parallel to the axis of rotation of the planet. So you can envision this as one spiraling to the right upwards. However, what's really interesting is that these zonal winds actually alternate. So one could be spinning to the left, let's say, and right next to it there's one spinning to the right. Enveloped by these winds is what the two complementary theories refer to as the metallic hydrogen dynamo layer. And essentially what this is really hot and high pressurized hydrogen, and when it's under a tremendous pressure and at very high temperatures, it becomes metallic, meaning that its electron becomes unbounded. And when this occurs, it's churning around, similar to how the outer core of Earth generates our magnetic field. That hot iron churning around the charged particles generates magnetic field. And so a similar thing happens in Jupiter, and that's what they believe to contribute most of the magnetic field. However, the hyperpolarized regions of which I was talking about is the third theory that acted almost as like a process that should be accounted for, but it doesn't, like I said, it doesn't undermine the other two. So it's important to figure out what's generating this magnetic field so that we have a better understanding of what's happening on other planets. And one way of doing this is probing Jupiter's atmosphere with a Raman spectrometer so that we can quantify how much orthohydrogen is where, and if it is aiding or enhancing the overall field of the planet. Thank you.